Hello everyone, I'm Dr. Tanmoy Biswas. I welcome you all in my YouTube channel TanmoyChem and Facebook page Chemistry the Mystery of Molecules. Today's topic of discussion is a multi-step reaction. I request everyone please pause the video, try yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start now. Look at the question. What is the major product of these multi-step reactions? So this is an alkene and four different steps are provided associated with different type of reagent. Before going to the details, let's learn the concept associated with the process. Now, what is the concept? Electrophilic addition on alkene, I mean in this case halogenation, takes place under ambient condition. Now, if you provide higher temperature, that case instead of electrophilic addition to double bond, there will be allylic substitution. And here if you look at 20 degree centigrade ambient conditions, so addition reaction will take place. Next, tertiary alkyl halide prefers SN1 reaction under ambient condition as the produced carbocation is tertiary, means comparatively stable. Next, chlorohydrin means adjacent carbon, chlorine and OH on treatment with alkene results epoxide by intramolecular SN2 reaction or Williamson ether synthesis type reaction. Next, protonation of epoxide, which is nothing but a cyclic ether followed by heating, result rearrangement reaction by 1,2 hydride shift to produce carbonyl compound. So you may compare this thing with pinacol, pinacolon rearrangement, as epoxides you may consider dehydrated form or ether form of 1,2-diol. Next, acidic opening of epoxide ring follows more stable carbocation as intermediate. So this much steps or concept will be utilized, then this stepwise reaction. Now, first step, chlorine at 20 degrees centigrade. So obviously chlorine addition to alkene, and by the way remember this addition is anti-addition, that's why look at the two chlorine position anti to each other. In next step, reaction with water, what happened? See, if you look at this carbon, this is a tertiary carbon, and this case this is a primary carbon. So obviously if this chlorine goes, it will produce tertiary carbocation, and here primary carbocation. As tertiary carbocation is comparatively more stable, means this chlorine will undergo solvolysis or hydrolysis or SN1 reaction to produce the corresponding tertiary alcohol. Now, these tertiary alcohol reacts with calcium hydroxide. Remember, calcium hydroxide is weak alkali where this OH minus can abstract this proton. And what it can result? These oxygen anionyl lone pair can attack backside from this chlorine, and via SN2 pathway, it can result epoxide. Now, you may ask one question, sir, chlorine addition to alkene results this opposite addition or anti-addition, that I agree, but SN1 reaction follows a carbocation, actually tertiary carbocation as intermediate. Now, if you consider that OH means obviously from water, this OH group can attack top and bottom. So what I can expect, this chlorine versus OH orientation should be seen anti both. But here I am showing only the anti product. What about the syn one? By the way, if you think syn product, I mean chlorine here, this case this is OH and two methyl groups are there. That can also react because this is a CC single bond, so CC rotation allowed, and by this rotation it can attack. Another thing, remember there are two methyl groups here. So this is called gem dialkyl effect or dimethyl effect. So because of that, ring formation is favored. Now what it result? It result this epoxide derivative. Next reaction is with H plus. By the way, if you look at H plus acid, so obviously it will react with this ether. Now previously, because of this carbon oxygen bond, this carbon is delta positive, this is also delta positive, but after the addition of proton, the electron deficiency on this carbon increased. Now if you look at this, carbon is actually primary and this one is tertiary, so that's why this bond breaks more efficiently. And what it result? By the way, in such cases I suggest you write everything as it is and focus on the place where the bond breakage took place. So here this bond broken, so positive charge here. This is a tertiary carbocation. Now these tertiary carbocation, if you look at, this is comparatively stable undoubtedly, but what can happen? These lone pair, actually as I told, this is some type of pinacol pinacolone rearrangement. So what happened? There is one hydrogen, actually two hydrogens there, one of them, so it can push its lone pair, and these hydrogen 1,2 hydride shift, This is hydride shift, means this hydrogen is migrating with pair 2 electrons here. So what it will result, by the way, there will be a positive charge generation because hydrogen is migrating with this bond pair, and that positive charge will be stabilized by the involvement or NGP with this oxygen lone pair. So what it will result, student write as it is. Now here this oxygen was neutral atom, it gave pair of electrons, so that's why there will be a deficiency of electron that is designated by positive charge. Okay, so this is the carbon attached with this, so there are two CH3. Now in next step what can happen, these can remove one H plus, means this H plus, what it result, it can result this aldehyde derivative. So this is the reaction. By the way, there was two hydrogens and here one hydrogen gone, so one more hydrogen remaining, that's why it is a CHO. So this is the product. Now what is this aldehyde? Yes, option D is the right answer. Now if you get this question, how could you do it very fast? By the way, in this case I personally suggest more reading, more practice, and you don't need to write all the steps, but few steps you can write. For example, chlorine addition, anti, fine. Water tertiary hydrolysis, then base calcium hydroxide, weak base but base, so it's an epoxide, and epoxide if you heat with H plus there will be a rearrangement. Now if you understand this much, so obviously epoxide will not stay, alkyl will not be there. Now your question will be, sir, it's 2-butanone or aldehyde, how can I understand? For that purpose you should draw the epoxide only and think what can happen. So obviously it will open as tertiary carbocation, these will migrate, so obviously this side CH2, so aldehyde, so D is also not possible. So little understanding, lots of practice, you can do it, this multi-step reactions. So this is the overall discussion. I believe this video may be useful. Thanks for watching. See you in my next video. Bye bye.